let us come to deep learning. Okay, a topic of our interest. So deep learning, if you see that uh, a very simple example I'll take. Whenever we all go to kitchen, so we are working with something, and sometimes we forget that what is hot, and we touch that particular plate or a bowl, something which is very hot. And now if you touch something which is very very hot, what happens at that point of time? What happens? Like, let's say the hand is on a very hot plate. So is it like we start thinking what to do, what not to do, whether I should remove or not? It's never like that. So what we do is, like, there'll be a reflex action. Immediately we will um, take the hands back. So now tell me, what is the reason for that? What is this phenomena of taking the hands back?
Reflex action,
Yeah,
sir.
yeah. So it's a reflex action. And the interesting thing is that the brain doesn't need to, get much involved into a great thinking over here to make a decision. So all the body has got cells, and especially I'm talking about the neurons, the neural cells. They immediately get an input from that particular hot plate, that that particular message of touching a hot plate is transmitted from few hundreds to thousands of the neurons which just get in touch with that particular hot plate. They transmit it to another hundreds and thousands of the neurons, and this message passing happens within microseconds, and they give a command to the muscles, and the muscle basically takes action, and that results in reflex action. The hand goes back. This is what happens. Now, this situation, if you understand, the hand actually went into a problematic situation, and then the neural network, the biological neural network, was able to find a solution. And the solution which this biological neural network was able to find, this solution actually helped um, us to get saved from that particular situation. Now, if we try to imitate or if we try to mimic this particular behavior, that actually is called as artificial neural network, and that area is now very popularly known as deep learning, or we call it as deep neural learning. Okay, so by different names we call it as, but as a standard term we have deep learning. So deep learning is coming from artificial neural network, biological neural networks, and they basically do transmit the information in a very quick and a responsive way, which help us to save from certain situations. Now, let's get into some technicalities of deep learning. So, deep learning is a part of machine learning that deals with algorithms inspired by the structure and function of human brain. It uses artificial neural networks to build intelligent models and solve complex problems. We mostly use deep learning with unstructured data. Okay, now here we can see, and already we have seen the whole of the system. Now this only talks about artificial intelligence, machine learning, and deep learning. So artificial intelligence, it is ability of a machine to imitate intelligent human behavior. So I was explaining this, that a machine can be intelligent enough, but if you see that the products of artificial intelligence, they work on a specific area or specific domain. Like if you go to hospitals, we have so many devices which help the doctors for surgeries, operations, taking out some readings, and making out some medication to the patient. So all these things happen with the help of artificial intelligence. Okay, but what happens? The artificial intelligence has got a special area which is called as machine learning, which is again very important. So in case of machine learning, what happens? The application of AI that allows system to automatically learn. So if there is a AI based application and it is not learning, then basically it is not of much use. Okay, without learning, it is of not much use. So machine learning is that particular area, that particular part, which basically allows the system to learn automatically and keep on improving. That is the machine learning area in the artificial intelligence. And deep learning is, it is application of machine learning or specialization of machine learning. It uses complex algorithms. The algorithms which are based on neural networks, they are called as complex algorithms and deep neural nets to train the model. So this is how is the relationship between artificial intelligence, machine learning, and deep learning. Okay, now let us move ahead and try to understand what exactly is a neural network. Okay, so what exactly is neural network? We just discussed that yes, there's a biological neuron, right? So the biological neuron, it's a cell basically. It's a biological cell. And let me show you some maybe um, diagram over here. So here, so look at this. This is a biological neural network. Okay, you can see here. And this biological neural network, if you see, it's like a it has got so many branches. Okay, so what are the components? This is the cell body, and soma we call it as. We have the dendrites. These branches are known as dendrites. The tail-like structure is called as axon. There's a cover on top of axon which is called as myelin sheath. Then again we have synapses. Synapses are those points where basically dendrites are getting touch connected to the dendrites of other um, cells. Okay, because we know that they keep on passing the messages. And soma, we discussed, that is a cell body. Okay, so this is a very simple basic structure of biological neuron, and they basically transmit the information from one cell to another cell. Okay, so very powerful and wonderful mechanism they have. Okay, let's go back. So what exactly is a neural network? So neural network, if I want to create a artificial neural network now, so we are focusing on that part. So neural network is a machine modeled on human brain. Okay, so like an attempt to mimic the human brain. We have multiple layers, and each layer consists of some nodes. Now, the connections between the nodes depict the flow of information from one layer to another. So here is a diagram. I'll show you the diagram. The neurons are connected with the help of weights. It then feeds the input to a neuron. After this process, the idea and gives an output. Okay, it processes the data and gives the output. So here you can see this is an example. Okay, so in this particular case, you can see that we have uh, we have certain inputs. Okay, the blue colored ones, these are inputs. And then we have here you can see the neural network cell, a single cell we have, and it gives the output. This is what happens. Okay, now to make it very simple, I'll show you something. Okay, very simple. I'll make it. Okay, I'll make use of Jupyter notebook. So let me use that. Okay, so here you can see that this is Jupyter Notebook, and I'll help you. Okay, don't worry. Like in order to work with anything, I'll help you. Now I'm just demonstrating a simple thing. So this one, okay, the presentation which we were seeing this, we have some inputs, we have some output. Okay, so in this particular notebook, what I'll do, I'll create some inputs. As of now, I'll create one input only. Let's say that is present as a list. So here input I have taken as 1, a single value I have taken. Okay. And then what I will do is I will create a function. Okay. Because this neural network, this node can be a function. It is like a function only. So what I'll do is I'll create a function def and nnet. Just I'm saying neural network. Okay. It will get some data. So I'll just write data. So here what to do? Now this function will do something with the input. Okay, something with the input. So here we will have some weight. Let's say weight is 0.5, and we will have some bias. Let's say some. So we'll understand these terms later. Don't worry. 0.2 is bias. Okay, and let's say output. Output is equal to And uh, so let me take output as empty list, and then what I will do for in inputs, I'll I'll store dot append whatever we will compute. Let's say it will be res. We'll compute res. So here res is equal to, we'll do I into into we have to do. So I into 0.5, then multiply this thing WNB. So I'll just do WNB. Sum OUT sum output. Or what I can do is I can just print the sum. So yes, this I will do. Okay, this is how. Now let me execute this. So here if I call this NNET and I'll put here inputs, execute, the answer comes as 0.1. And let's say input has got multiple values, then I'll be getting some different output. Okay, so this is how it basically works, the neural network. So here you can see that, so in this particular case, I have a set of inputs. You can see 1, 2, 3, 4 multiple inputs are there. So here also we have 1, 2, 3, 4 multiple inputs, right? So 1, 2, 4, 7 multiple inputs we have, and this input is sent to the neural node, and here you can see that this nnet is the node. This function is basically a node for me, and that function works upon it and gives some output, and that function worked on this input data and gave us some output. Okay, so a simple analogy I'm able to make, that how the a particular single node can be made. So the way here you see that the node has been made, similar way there can be multiple nodes, right? So this is a single node in the presentation we can see. There can be multiple such nodes, which will basically represent the neural nodes or channels, and the data will go into them, and they all will give some output. Okay, so that is how it actually works. So I hope this basic idea of node is clear, that when a neural network is implemented, then what do we have? We have inputs, we have neurons, okay, layer by layer, and we have output. Now there are very importantly three layers: input layer, hidden layer, and output layer. Three layers are there. So in this particular case, if you see in the diagram, so it is just one neural cell is there. Okay. But if I'm talking about layers, so I'm really talking about layers. There would be layers only. Okay. Layer means more than one neuron would be there. And based upon that, the layer will be formed. Okay. So input layer will be there to accept all the inputs. So in this particular case, this itself is the input layer and it is accepting all the inputs. Then next thing is hidden layer. This layer processes the input data to find out hidden information and performs feature extraction. Okay, so what is happening? So this layer processes the input data to find out hidden information. So it is finding out some hidden information. That is the objective of machine learning, right? So to the objective is to create a mapping function. But how to create a mapping function? By identifying the hidden information and by extracting the features also, that which features are actually explaining the output more. And then we have output layer. The output layer gives the final output. This is how the layers are organized in case of neural network.